We can start. Let's share you the screen. Yep. Okay. Can you see the screen?
Yeah.
Okay, good. So let's do together the question. Question number 1 is the normal to a certain loop area with 1 meter square makes an angle of 60 degrees with a uniform magnetic field. The magnetic flux through this area is the same as the flux through the second area that is perpendicular to the field. If the second area is how much? To be the field is the same.
Okay.
To be the field is the same, for example, in the first area, given the area 1 meter square, yes, given area 1 meter square,
Yes.
and the angle between the normal line to the hello ይሰማል?
ይሰማል።
አጋጣሚ መብራት ጠፋ፣ ኔትወርኩ ይቋረጥ አይመስለኝም። እስከሚቋረጥ ድረስ መጠበቅ እንችላለን። So the normal line to a certain area is 1 meter square and an angle theta is 60 degrees with a uniform magnetic field. The magnetic flux through this area is the same as the flux through the second area that is perpendicular to the field if the second area is blank. We use here cos theta or sin theta?
If we use cos, then the second area will be 0.
No, why the second area? Given area 1 meter square, yes, this one. This is sorry, why it is like this? So given the first area is 1 meter square, yes, area 1.
Yes.
Theta is 60 degree. So this theta is the angle between the normal to the area and the magnetic field. So in this case, we use to find the magnetic flux, we use BA cos theta, yes?
Yes.
Good. So the magnetic flux through this area is the same as the flux through the second area that is perpendicular to the field. That is perpendicular to the field. If the second area is, therefore, magnetic flux 1 is the same as magnetic flux 2. Magnetic flux 1 is BA cos theta. That means B times the magnetic field B times the cosine of 60 degrees, which is the same as for the second flux, the magnetic flux through the second area is BA cos theta.
Theta.
Yeah, but what is the angle between the second area and the magnetic field?
Isn't it?
Is it
Or
0?
zero?
Is it 0 or 0? Is it 90 degree or 0?
90.
90 perpendicular to the field in the second area. The flux, the magnetic flux through this area is the same as the flux through the second area that is perpendicular to the field. Perpendicular to the, is it the normal line, or the normal line is perpendicular to the field, or the area is perpendicular to the field?
The second area.
Yeah, for the second area, the normal line to the area and the field, the angle between the normal line to the area and the field is 0 degree, yes?
How 0?
Because the area is perpendicular to the field. And what is normal line? The normal line is the line perpendicular to the area, yes?
Yes.
So, if that is perpendicular, therefore the normal line to the area is in the same direction to the field.
So they are 0?
Yeah, the angle is 0. Therefore, there is a maximum magnetic flux in the second area. That means area to times magnetic field B.
Mm.
And,
1.5. The cos 60 is 1.
yeah. Therefore, area 1 is 1 meter square times magnetic field is the same. We can cancel out both sides. Yes?
1/2 is equal to A cos 0 is 1.
So what is
the area is 1/2.
What is area 2?
1/2.
Very good. 1/2 means 0.5 meter square. Therefore, the correct answer is option C. Is it clear?
Yes, yes.
Good. Let's see the second question. Faraday's law states that an induced EMF is proportional to what?
Rate of change of magnetic flux.
Very good. The rate of change of magnetic flux. Let's do the questions together. By the way, I can make it like this. Okay, let's write your name here. Can you see the screen?
Yes.
Okay, good. Let's go next. So the first one is 0.5, yes?
Yes.
Good. The second one is Faraday law states that the induced EMF is proportional to the rate of change of magnetic flux. Therefore, the correct answer is option C. What about question number 3? In purely capacitive circuits, the current
Lead the voltage by 1/4.
So in purely capacitive circuit, the current leads the voltage by what?
1/4.
1/4 means 90 degrees, yes? So the correct
Yes.
answer is option A. And in purely resistive circuit, the current is?
In phase with the voltage.
Yeah, in phase. The angle between the current and the voltage is 0 degree, therefore it is in phase. Option D is correct. And in purely inductive circuits, the current lags the voltage by?
90 degree. 1/4.
Yeah, 1/4 of the cycle is 90 degree. Very good. And let's see question number 6. A coil has a resistance of 60 ohm and an impedance of 100 ohm. Its reactance in ohm is blank.
Impedance is equal to resistance plus reactance, right?
Yeah, for this case, there is no capacitive resistance, yes?
Yes.
So we have to use square root because they are imaginary number. From the phasor diagram, yes? Therefore, the impedance is under
Yes.
square root, the resistance square plus XL minus XC whole square. In this case, XC is 0. Therefore, under square root 60 square means 36,000, yes? Plus
Yes.
10,000 under square root. You can use the calculator.
Okay.
The square root of 36,000 36,000 plus
116.6.
10,000. How much you got? 116.6. Yes? So, which option is correct in the series significant figure?
D.
Yeah, option D is correct. And question number 7. A reactance in ohms of a 35 microfarad capacitor connected to a 400 hertz generator. What is the reactance for this capacitor circuit?
1 over omega C.
Omega is omega
2 pi.
2 pi f. Therefore, you can use again the calculator. 1 over 2 times pi is 3.14 times the frequency is 40,000 times the reactance is 35 times 10 to the power of minus 6 farad. Mm-hmm.
100 times 5 times
1 million divided by 2 pi is 6.28 times 400 times 35. Finally, you will get 11.37, yes?
Yes.
So how much you got?
11.64.
Yeah,
Like this.
in two significant figure, the answer is 11. So let's see question number 8. The impedance of RLC series circuit is definitely increased if A, the capacitance decrease, B, the inductance increase, C, the resistance increase, D, the resistance decrease. Which one is the correct answer?
See resistance increase.
Yeah, very good. So because the impedance is given by under square root r square plus xl minus xc is whole square. Therefore, when, for example, the inductive circuit increase, maybe the capacitance circuit again increase, there is a variation there, but it is always increase when the resistance is increased, yes?
Yes.
Good, option C is correct. So let's see question number 9. RLC series circuit has resistance 4 ohm, capacitive reactance is 3 ohm, and inductive resistance is 6 ohm. The impedance of this circuit is
5.
good. So under square root 4 square plus XL is 6 minus 3. 3 square, 4 square is 16. 16 plus 9 is 25. Under square root of 25 is 5. Very good. The answer is option A. Then let's see question number 10. A sinusoidal voltage BT has RMS value of 100 voltage. Its maximum value is B peak. What is a B peak?
VRMS over 0.7 will be 141.
141. So the root mean square voltage is the same as I peak over root 2, yes?
Yes.
So what is I peak? Sorry, B peak. B peak is 100 times root 2.
Yes.
So what is root 2?
0.7.
Root 2, okay.
2 will be 1.4.
1.4. 1, yes? The answer is option D. Very good. Let's see question number 11. A series circuit consists of 50 ohm resistor and 25 millihenry inductor and 35 microfarad capacitor. If the frequency is 100 hertz, the power factor is blank. What is power factor?
Real power over apparent power.
Sorry?
Real power over apparent power.
So what is that value?
Calculate for power.
So that the power factor is the apparent power divided by the real power, yes?
Yes.
So it is cos theta, yes? So
Yes.
the power factor is cos theta. What is theta? Theta is the phase angle, yes?
Yes.
How do you calculate the phase angle from this information?
From cos inverse of theta.
Tan inverse of
Tan inverse of theta.
XL minus XC over the resistance. Yes?
Yes.
So tan inverse of XL is, you have to change the units in, there is a unit, yes?
Yes.
So tan inverse of XL is 25 times 10 to the power of minus 3. And the capacitance is 35 times 10 to the power of minus 6. Therefore, and the resistance is 50 ohm.
XL is different from the XL is different from the inductor.
Yeah.
Inductor.
So why we subtract? Hello?
Yes, hello.
Yes? I mean, this information is what? This is capacitance. This is inductor, yes? So
Yes.
we have to find XL and XC. What is XL? XL is omega times L, yes?
Yes.
And XC is 1 over omega C. We have to calculate that in resistance, in ohm.
Will be 200 pi. 200 times pi.
2 pi 628 times 35 times 10 to the power of minus 6 is for the XC. XC is 1 million. 1 million divided by 2 pi f means 2 pi is 3.14, 2 times 3.14, 6.28 times 35, 6.28 times 35 gives XC. Therefore, XC is 4549.59. So have you saved this number? 45,
I am calculating it.
4549.59 is XC. And let's calculate for the XL. XL is omega times L. 6.28 times 25 times 10 to the power of minus 3. 25 times 10 to the power of minus 3 is, so times 10 to the power of minus 3, 0.157, yes?
Yes.
So let's
15.7. 15.7. Yes,
15
over 15.
for XL, omega times L, yes? Omega is 2 pi f, 100 times
Yes.
6.28, 628 times 628 times 25, 628 times 5 times 25 is, yeah, divided by 1000 for millimeter, the millihertz. So 15.7, very good. Minus what was XC? 45, 49.5905. The angle is negative divided by the resistance is how much? 15. Finally, the difference is minus 302.25. The angle is negative, therefore tan of this angle, okay, tan inverse of this number. Tan inverse
I
of
got 0.45.
0.45 is the power factor cause of that angle. Yes?
Because it will be 0.69.
59.
6. Mm,
XL minus XC. XC is 1 over 1 million divided by 35 times 6.28. Have you got the final answer?
XL will be 5 pi. XL will be 5 pi.
5,
15.7.
10.7.
Yes, 15.
Okay. 15 XL, yeah, XL is 15.7. What about XC?
XC will be
1 million divided by, because microfarad.
35. Yes.
35 times 628.
45.4.
Sure, okay, 45.4
Yes.
divided by 25
Mm.
minus 1.188. What is tan inverse of this number?
Negative 63.
Negative 63.
Yes. And
So,
cos of that
cause of
number is
this.
0.449.
Oh, therefore,
0.45.
okay, very good. Therefore, option C is the correct answer.
Yes.
Very good. Let's see question number 12. A step down transformer is used to what?
Decrease the voltage.
Yes, option D is correct. Let's see question number 13. An AC generator producing 10 volts. This is a root mean square voltage at 200 rad per second. This is the frequency, yes? Angular speed is the same as frequency. Is connected in series with a 50 ohm resistor and a 400 millihenry inductor and a 200 microfarad capacitor. Then the root mean square voltage in volt across the inductor is how much?
How do you calculate this?
Okay, so the root mean voltage across the inductor. What is the voltage across the inductor? We have to calculate XL and XC again. Do you remember the total voltage is the same as the real voltage plus BL minus BC under square root? We can square it both sides. Then the current passes I peak is the same for all because the circuit is in series. We have to calculate the total current. If we calculate the total current, that total current I root mean square times the XL gives voltage across the inductor, yes?
Yes.
Did you understand it?
Yes.
So let's calculate the total voltage here, or the impedance times, we have to calculate the impedance. 10 volt divided by the impedance gives the current, yes? So calculate the impedance. 50 square means 25,000. Yeah, we are here. So let's bring our calculator again. So what is XL?
XL 2 pi F L
XL is 2 pi F 628 times 2. 628 times 2 give us 1256 times XL is 400 times 10 the power of minus 3, yes? That means times
100 rad per second.
0.4.
The 200 is omega, right?
That? Yeah.
2 pi.
This is omega, yes? Omega, yes.
Yes.
This is omega, very good. Because the angular frequency is the same as omega, yes?
Yes.
Because for one complete oscillation, the angular displacement is 2 pi. The time taken is period. Therefore, 2 pi over period is omega. This 200 rad per second is omega. Yes, it is omega. So omega times XL, that means 200 times 0.4, yes? Is XL, 200 times 0.4.
80.
Yeah, 18. This is XL.
XC will be 25.
So what is XC?
25.
Okay, is it 25? So what is impedance? Under square root?
50 square plus 80 minus 25, 55 square.
Okay, therefore 25 square is 625,000, 50 square. 5 square is
Will be
25, 2,500 plus 80 minus 35 is 55, yes? 55 square,
3,025.
so it's
The final
1,025.
answer of the impedance will be 74.3.
Impedance, Z, 74.
3.
Therefore, 74.3 divided by, the 10 voltage divided by 75.3, 74.3,
24.
0.134, yes?
Yes.
This times the XL was 80, yes?
Yes.
This gives the voltage across the inductor. 10.76. Therefore, the correct answer is
Yes.
what? Option D. Let's see question number 14. RLC series circuit is connected to an oscillator with a maximum electromotive force of 100 volt. If the voltage amplitudes BR, BL, and BC are all equal to each other, then what is the voltage across the resistor?
How we calculate?
I mean, BL, BC, BC are equal, yes? What is the total voltage? The total voltage is under square root BR square
VR
BL minus BC the whole square, because BL and BC are equal, therefore that is 0. Therefore BR was 100, the whole square gives BR square, and then both sides is square.
will be VR.
Yeah, the same as the total voltage. Yes, it should be 100 volts.
Yeah.
Very good. Is it clear?
Yeah.
Good. Let's see the last question for this quiz. We desire to make LC circuit that oscillates at 100 Hertz using an inductance of 2.5 Henry. We also need to say capacitance of what? This is just, you can use the resonant equation where the XL is the same as XC, yes?
Frequency will be 1/2 pi radical LC.
Yeah, therefore calculate for C.
Yes. Yes.
How much you got?
1/200 pi radical L.
So use calculator and let's put the answer.
One times 10 the power of -3.
1 times 10 the power of -3.
Yes.
So 1 millifarad, yes?
Yes.
So the correct answer is option B. Let's see our answer together. Let's submit it. Your response has been recorded. Do your score. Let's see our score. So we get 12. So there is a wrong answer. Maybe I will make a mistake when we check for the answer. Let's see together the wrong answer. The first one was correct, the second one correct, the third one correct, the fourth one correct, the sixth one. Why? A coil has a resistance of 60 ohm and impedance of 100 ohm. It's reactant. Come on, we missed this one. We calculate
40.
40. The correct
Yes,
answer.
because the impedance
800.
equal to the total. Yes.
Okay.
150.
The impedance is Z, yes?
Yes.
So Z is under square root R square plus the reactance part, the whole square. So 100 square is 10,000. Therefore 60 square is 36,000. 10,000 minus 16,000. It is how much? 64,000. Therefore, the correct answer is C, yes? 64,000 under square root is the reactance part. Yeah?
Yes.
So just we jump this part when we read in the previous slide. This is the impedance. Therefore, this is Z, yes?
Yes.
Good. Let's see another one. The impedance, the impedance. This is wrong. The answer is correct, yes?
Yes.
Yeah, but it's the answer is R increase. Our answer is correct. So we got 13. So let's see another wrong option. This is for the impedance. The last one. Have you done it correctly?
Yes.
You
The
can.
formula for the radical C,
I
it will
mean,
be
XL equal to XC, where XL is omega times L and XC is 1 over omega times C. Then calculate for C. If you do in that way, you are correct. Maybe I will made a mistake when we set the answer for the question, when I prepared the cues.
no, teacher. We have to square 1 times 10 to the power of negative 3. 1 times 10 to the power of negative 6C.
Negative?
6.
Oh, so it is microfarad.
Yes.
So
Not
the
really.
option C is correct, yes?
Yes.
So, okay, good. Is it clear? Chapter 7. Any more question?
Yes. No.
So we have around 10 minutes. So let's go for chapter 8 or let's stop here. It is up to you. You have 10 minutes.
10 minutes. We will continue tomorrow.
So we will continue tomorrow. So it is enough for today. Prepare yourself for chapter 8. We will finish it tomorrow and we will do Q's Saturday on that part. And next Tuesday, we will start grade 11, chapter 6.
Okay.
Thank you very much. Have a nice time.
Welcome.
Okay, good.